The Marine Canvas Training Institute presents its video classroom series. In this tape, Don Wedge demonstrates his method of how to design, measure, and bend a typical marine canvas product's frame from the initial conceptual stage to installing the fittings. Now here's the Marine Canvas Training Institute's president, Don Wedge.
We're going to talk about frame design and bending. It is probably one of the most important things that a canvas fabricator has to do. There are a lot of people out in the world fabricating canvas that are doing real bad designs. And we don't believe in that here at the Marine Canvas Training Institute. We try to design things that will make the boat look better than when we started. In other words, we want to enhance the lines of the boat. How do we do that? Well, we don't build square and uglies. We make our frameworks make that boat look better than when we started out. I have here a folder that will show you some of the different products that require a frame to support them. And you'll notice here that we have a convertible top, requires a frame. We have a camper enclosure, which requires a convertible top frame and a camper top frame. We have a bimini top frame, which can be used on a flybridge, can be used in the center console of a sailboat, it can be used on an aft cockpit sailboat, and it can be used on a center console fishing boat. On the other side of the brochure here, we have some Dodgers which require frameworks. And those are the things that we're going to be talking about today as to how to design the frame and how to bend it to fit the project that we're going to have. Now, one of the most important things in designing framework and bending frames is what do we design to? You'll have to learn this, that boats are not built plumb level and square. Boats are built crooked. They have rounded lines, and we have to make our framework make those lines look better. So the starting point for all frame design is this. Find the center line of the boat and build everything that you build to the center line of the boat, disregarding the fact that the windshield might be out of square with the center line by an inch. Because if you try to build to the windshield, you may have your canvas running right off the corner of the boat. So we're going to show you right now how to find the center line of the boat. And up here on the board, I have drawn a picture ahead of time of a boat. May not be the best picture in the world, but it's a top view of a boat. It has the outline of the windshield shown here, and I've drawn a center line. Now this one I drew exact on this picture. Now how do I get that exact center line on a boat? Well, here's the way that we go about it. We do what I call triangulation. It's pretty easy to find the center line on the bow because you can look and find the real center on that. It's fairly easy to find it on the stern because you can measure across. But what are we measuring across? Those points are the things that will help determine how we triangulate this boat. So what I do is I look on the boat for some place on the back corner of the boat that was designed into the mold that would be symmetrical on both sides of the boat. Because when they build molds, they spend an awful lot of money building a nice mold. What we do not do is ever measure from something on the boat that was put on there by a mechanic or a man or somebody like that, because they don't always put them in the same place on the boat. So we look for a place on the mold that is consistent. What do we do with those two places that we find? We take our ruler, and I'm going to draw them on here. We're going to assume for the moment that I found a point on this corner and a point on this corner that were consistent on both sides of the boat. What I do is I hook my ruler on this corner and I measure across the center line of the boat to some point on the windshield. And where my ruler touches the windshield here, I will take a reading. And let's just assume for a minute that when I measured up here, my ruler hit the windshield at 98 inches. So I would put 98 inches right there and just put a mark on the windshield. Now to find the center line using the other corner of the boat, I'll hook my ruler over on the starboard side at the corner and bring it up across the center line of the boat, and where 98 inches intersects with the windshield, I'll draw a mark. and now I've got 98 inches over here. How do I find the center line? If I measure from this mark to this mark and take half of it, I have now established the true center line of that boat. And that is what we will be building all of our frames to. Now, I don't have a picture of a sailboat up here, but all of the same rules apply when it comes to a sailboat. You'll find the center line of the bow. Masts are built into a sailboat in the center of the boat. I've never seen one that wasn't in the center, so we'll find the center of the mast. We'll find the center on the stern, and if I have to make sure that my product is right, I will string a line from the stern to the mast to the bow. I'll do the same thing on a powerboat, because everything that we build will be built square and true with the center line of the boat. Okay, now that we've established the center line on the boat, I've put a drawing up here on the board of the most used frame configurations that are used for all of the products that we have to build for boats. The reason I put these up here is so that you can have an idea of what kind of a frame you have to design. So I've got these 5 pictures here, and I'm going to start up here in the top left corner. This is the general configuration that would be used for a convertible top or a navy top. The next picture on the right shows the general configuration of a framework that could be used for a convertible top, a Dodger, and a spray hood. Now, why do I have 2 different pictures for a convertible top? The reason is this. Years ago on the older boats, the first picture, you were able to mount your top on the coaming or someplace down in the boat or on the side panel. Nowadays, the way they're building boats, we've had to change our configuration a little bit because the majority of the windshields are rounded windshields, and there is no place to mount the framework on the coaming. So we have to mount on the windshield. So consequently, when we get into the design and how to figure the leg lengths, it's going to require this general shape of a framework. The next framework that we might be using would be for a bimini top, which is this picture here, and we call it a single mount 3-bow bimini top. The next configuration that we would be using would be a single mount 4-bow bimini top. Now I need to stop right here for a minute and say, why would we go from a 4-bow to a 3-bow bimini top or the reverse? The reason is we have some rules that we go by as to how many frames it takes to build a particular project on a boat. And our rules are that we never go over 36 inches from frame to frame to frame. Same would be true on a 4-bow top. Same could be true on a Dodger or a convertible top. On a convertible top, you'd be going from windshield to frame to frame. The bottom picture down here shows you a 4-bow split mount bimini top. Why is it even needed? Because on center cockpit sailboats, many times the place that you want to mount your top is right in the middle of the area, and there's always going to be a winch or some crazy thing there so that you can't get the frame mounted where you want it. So we would split them out so that we could have a winch here and we could gain a little more length. This also can be done on some of your fly bridges where you have to have a very short frame as far as height, but a very long frame as far as overall length. So these are the 5 most commonly used configurations of frameworks for boats. Now, I'm not going to take the time to go through what all of these things mean, but let me tell you this, that in order to design and bend frames with the system of bending that we have to know what the main leg length is. So on every one of these pictures here, you'll see that there's an X. And the leg lengths for all of the frames that attach to the main frame will be done by formulas. And I have taken this sheet and I've put up here the formula for the leg length for all of the succeeding frames that have to attach to the main leg. So later in this tape, we're going to get to the point of teaching you how to determine what X is, and all of the rest of the leg lengths will be determined by formulas. And you'll have plenty of time to look over this complete chart and see what those formulas are. Continuing on with design of framework for boats, I have here on the board what I call the design rectangles. It's kind of a crazy name, but it's the only thing I could think of. But when I walk up to a boat to design something for it, the customer's already called me and he told me he wants a particular product. So as I'm walking up to the boat, I have a mental image of a rectangle standing on edge. So I've tried to draw these rectangles on all of these configurations of boats. And this rectangle right here is what I'm trying to explain to you. This dotted line represents that rectangle. What we're looking at right here is a convertible top. So my question, or what the rectangle does for me, is this. It helps me establish an overall length of the area that's got to be covered, and it helps me establish a height of the area that has to be covered. So this is the rectangle that I'm trying to talk about. And this does one more thing for me. It helps me establish the configuration of the framework that might be required to support the canvas. It will also help me establish a mounting point. I'd kind of like to go through all of these different configurations with you so that you know what I'm talking about as I talk about these rectangles. This is what I would look at for a convertible top. The next picture that I have over here is for a flybridge bimini. You've got the cruiser with the flybridge on it. Here's your windscreen that's faired out to the front. The man wants his flybridge covered with a bimini top. So I look at the area that has to be covered. This gives me a height and a length. Now we'll move on down to the next picture, which is a convertible top with a camper top. We have the same as the first picture, but behind that we've added another set of frames and another rectangle that establishes the length and the height of the camper top frame that we have to build. We move on over to the next picture for a Dodger on a sailboat. Normally a Dodger on a sailboat, the area that you would have to cover would be just forward of the companionway. And we always try to finish the Dodger approximately 6 inches after the companionway opening. Why? So that when the Dodger's up and it's raining or the boat's taking on water, it doesn't shoot water down below. So here's the rectangle, height and length. Moving on down to a center console fishing boat, you have a spray hood, which is nothing more than a Dodger on a sailboat, except that they call it a spray hood because it's on a power boat. It does all of the same things. It protects you from the spray and the elements. So again, the same rectangle from the combing up for height. Length is determined by coming back and trying to cover the step that's built into the boat and still allow room for the customer to walk around this console, which is this thing right here. So now we've established a height and a length. Moving on over to a aft cockpit sailboat, and we want to build a bimini top on it. We measure the area of the cockpit area that we have to cover. We get the height off of the deck, and that will be determined by the boom, because when we build a bimini top on a sailboat, we always build our tops so that they're at least 1 inch lower than the boom when the boom is sheeted down tight. So now that establishes height and length. Same old rectangle. Moving on down and back to a center console fishing boat. Some people want a bimini top on that. Normally we would want to cover from the forwardmost seat to the aftmost seat. So now we've established the length of the rectangle and we've established the height. What did we establish for height? We established 6'4". Why? That's an arbitrary figure that we came up with, but the average man is about 6 foot tall, so we make our bimini tops 6'4" tall unless he specifies otherwise. And if he has tall friends, we take a chainsaw and cut their legs off. Continue on down to a 4-bow bimini top on a center cockpit sailboat. I've got what used to be a Morgan 41, I think it was. Anyhow, it's a center cockpit here. That will establish the length of the rectangle, and the height again will be established by measuring from the mounting point up to 1 inch below the boom. On sailboats, you have to remember this, that you may not always be able to give the customer 6 foot 4 inches. It's your job as a fabricator when you sell a bimini top on a sailboat to make sure that you either get permission from the customer to put the mainsail up and sheet it down tight in the middle of the boat, or have him do it and set the topping lift so that the boom will never be any lower than that. Then you build to within 1 inch of that point. Now, back to my rectangles, okay? When we're designing frames, it's your job as a fabricator to figure out where you're going to store these tops. And they get worse and worse to figure out as we go along. This is the new style of convertible top on the newer style runabout type boats. And again, I said they had to mount on the windshield, and many times they have to store over here behind the back seat. But again, it's your job to figure out where they're going to store and tell the customer where that's going to be. On the next picture over here for a bimini top on a flybridge, many times you can't lay it down to store it, because if you laid it forward, it would be laying out over the windscreen. If you laid it aft, it would be laying out over the back end of the bridge. So what do? I would draw another line here, and that would represent a stanchion for storage purposes. Then when you fold the top up, all of these frames fold up to this frame, and you put a boot on it so that it looks nice. That would be the storage position for that. Back down to a convertible top and a camper top. Most of the time, a camper top, you can make it lay on the stern of the boat. In the newer boats, again, this frame probably will have to come off and go down behind and under the back seat. Continuing back over to a Dodger, you got a 2-frame Dodger here. You can't store it aft because it's going to be right down in the cockpit, so it's your job to figure out how to get it to store by laying it down here. Now, I'm going to stop there just a minute and explain one thing about storage. Every one of these configurations for every one of these frame designs, the storage will be determined by where the main frame is, because the main frame will always be on the bottom of the pile. Why is it on the bottom of the pile? So that when it's in the storage position, which is laying down, the fittings that attach the other frames to the main frame won't be digging in the boat. So if you look at all the frames that I have on these drawings, you'll see that the main frame normally is in a position where it can just lay down and store. Back to my rectangles for a minute. Here's center console fishing boat. 2 frames. This is the main frame. It's going to lay down up here, and this frame will be on top of it. On over to the bimini top on a aft cockpit sailboat. Sometimes they'll lay down aft in front of the main sheet. Sometimes you got to lay them down forward. If they had to lay forward and up over the companionway, then you would reverse this set of frames and put the main frame forward and the secondary frame aft. Down to the bimini top on a center console fishing boat. Again, you see this one, I've already sketched in the stanchion. Why did I put a stanchion here as opposed to laying it down? Because it's a fishing boat. If I were to store it forward, it'd look kind of weird. So we're going to store it aft, and we're going to put a stanchion here, let all of these frames fold up, put it in a boot, and it's still a fishing boat because you can fish behind it, in front of it, under it, and up forward of it. When it comes to a 4-bow split mount on a center cockpit sailboat, again, the storage position will be determined by where the main frame can lay down. And you'll notice in this particular drawing that I have it storing forward because this frame can lay down up forward and be out of everybody's way. You'll also notice that down here on the bottom of the frame I have another fitting on here which represents a jaw slide that's put on there so that when we lay this pair of frames down, we can come back and pull a fast pin out of this set of frames, carry them forward, fold it up, and lay them on this set of frames and put the fast pin back in. And that takes care of the storage problem. I have to go back one more time on my rectangles, okay? When we go back up here to the convertible top, I hope this doesn't get too boring, but this is the design problems that you run into. When we draw this rectangle, it does a whole bunch of things for us. It establishes length, height, and mounting point. And the mounting point normally for most frames will be approximately half of the overall length of the rectangle. Or in the case of these little short frames on windshields, it will be half of the dimension from the secondary frame to the main frame, because you have to understand here, or you have to visualize where the canvas is going to go, which is from the windshield to the secondary frame to the main frame. Over here on a flybridge bimini, normally it'll be half of the overall length. And this holds true on all of these, but if you'll learn to use these rectangles in your designing, it will help you determine where the frame is going to mount, and that will in turn get to the point where it'll help you design the leg length for the main frame. And we're going to get into that a little bit later after we talk about the bender, but you do have to find the leg length in order to use the other formulas that I gave you before. I have here in my hands a bender, which we call the Bend-Right bender. Now there are a lot of benders on the market. Back when I wanted to learn how to bend frames, there were no benders on the market, so I had to design one. So this is what we call the Bend-Right bender, and for purposes of these demonstrations on these tapes, this is the one we're going to be using. It has some formulas that go with it. All benders must have a formula to go with them in order to work. For those of you that have other kinds of benders, if you need, I'll be glad to help you try to figure out a formula that will work. But for this demonstration, we're going to use the Bend-Right bender. Now the formula is this. We have to know two things to bend a piece of tubing into a frame for a boat top. We have to know a leg length, and we have to know a width. And from that point on, we can bend any frame that we want to bend. And this bender, by the way, will bend anything from 3/8 awning iron up through and including 1-inch stainless steel. And it also is done by hand, but it can be done by a 98-pound person that's soaking wet. So you don't have to be afraid of having enough strength to do it. So now I'm going to lay this down and I'm going to show you the dimensions that are required to be able to bend a frame from a straight piece of pipe. On the bender, you saw two marks. You saw one mark that had an LL on it for leg length, and you saw another mark that had a mark on it and it said CR for crown. Now to take a straight piece of tubing and lay it out and bend it to make it look like this frame right here, here are the things that we need. We need to know a leg length, which we call LL. Then we need to know a layout width, and we need to know a mounting width. This is our mounting width, this is our layout width, and this is our leg length. So I'm going to take a straight piece of pipe and lay it out with the formula. We lay out a leg length, we lay out the width minus 20 inches to get to the start of the next leg length. Now we use a particular system of marking on this bender for this reason. Everybody in the shop knows the same system, so that if I start a frame and somebody has to finish it, they know how to keep going. So to designate leg length, we use an arrow halfway around the piece of tubing. To designate width, we go width minus 20 inches and put an arrow for the start of the second leg while we have our ruler laying right there. We take half of this dimension here and put a line with a C through it, which represents center line. Remember the center line of the boat? Now we get a center line on a frame. Then we take the dimension from the center line to the leg length, and we put as many 8-inch increments as we can get on each side of center, and they are designated by hash marks. The last item is to come down here and establish another leg length. Whatever the dimension was over here, we make it over here. We got another leg length. And in Florida, we spell cut with a K. And now you have your tubing laid out with all of the marking ready to bend it. Now I'm going to show you how this relates to the frame after it's bent. After this is put into the bender and bent, these marks will all end up right here on this bent frame. Now the relationship of all of these is this. This is the leg length from the mounting point here up around the corner to this arrow. The layout width is the dimension from this point here to this point here. This is the layout width. and we just put LW for layout width. The mounting width is this point from where it mounts on the boat on one side to where it mounts on the other. 3 things that you have to know in order to take a straight piece of tubing, lay it out, and bend a frame. Now the first thing that we have to figure out is how do we find the leg length? And there are 3 ways to find the leg length, and I'm going to give you all 3 of them. One is using the leg of a triangle, which is a geometric way, and I'll do that on the board. The other one is we use the corner of the table, and it really sounds weird, I know, but we don't make scale drawings. We just take measurements and go make our frame. The other way is with the bent tent pole method, which you haven't even seen yet, but you will see that a little later in the tape. So again, 3 ways of doing this: leg of triangle, corner of the table, and a bent tent pole method. Now I'd like to show you how to figure out the leg length for the main frame of your frames using the geometrical way of figuring the leg of a triangle. I'm going to revert back just a minute. Remember our rectangle that we used for designing this frame on the boat. We filled up that rectangle with a set of frames. In this case, we used a 3-bow Bimini top frame. We have to know what the leg length of the main frame is to determine what the other 2 leg lengths are going to be. Now we have 2 known facts in this equation. We know the height of the rectangle, which is A, and we know half of the length of the rectangle, which is B. Now to find out what C is going to be, here's the route that we go. We take the dimension for A and square it. We take the dimension for B and square it. And A squared plus B squared will equal C squared. Continuing on, we'll take the square root of C squared and add 4 inches to it, and that will give us the leg length of our main frame. The reason that we have to add 4 inches to it is this: it takes 4 inches more length to get up the leg and around the corner over to the leg length mark on the piece of tubing that I had up on the previous picture. Now we're going to show you how to establish the leg length for the main frame on the top using the corner of the table. You'll notice here that I laid a ruler across here only in order to recreate this rectangle that we were talking about as far as how to design framework. So this is the length of my rectangle, and this is the height of my rectangle. Now, this is a predetermined figure by measuring the boat. This is a figure that's determined by measuring the boat. And normally on a top, the mounting point will be approximately half of this rectangle. So whatever the dimension is of the overall rectangle, we'll measure down here halfway and put a clamp there representing the mounting point. Now what do I have to accomplish is this. I have to know the main leg length, which is this one here. We're also going to have a leg over here for the secondary frame, and we're going to have a mid frame up here. But for purposes of getting the leg length for the main frame, it's as simple as this. A is an established height, B is established length. I measure from that clamp, which represents the top, to this clamp, which represents the mounting point. It's 57 inches. I take 57 and add 4 inches, and that represents the leg length of the main frame. It takes the extra 4 inches to get around the corner in the frame up to the leg length in relation to the bender. The main frame on a convertible top is the one that attaches the framework to the boat. This tent pole represents a framework. This mark on the tent pole is what we call our leg length. It's in relation to the bender. It was put on here before the pole was bent. We've established the mounting point. The customer told us that he wanted the top to finish 6'3". So I'm going to set my ruler at 6'3", and I'm going to use it like a plumb bob. And I'm going to set the tent pole on a mounting point. I'm going to see how the plumb bob falls in relation to the combing down here. And while all the time that I've done all of this, here's everything that I've established. I'm at close to a 45-degree angle to the mounting plane, level plane of the boat, which means that when I use the formula for the secondary frame, I'll have another secondary frame swinging off of this one up in here at a right angle. I've established the height. I've checked my angles. So all of a sudden, I've got my leg length. So while I got it right in my hand, just take and run my ruler right down around this tent pole to the bottom and take a reading, and it says 48 inches. Now that we're at the bending station, I'd like to take just a minute and give you some information about the kinds of tubing that we use. We made the decision a few years ago to use 7/8 058 wall aluminum tubing for the less expensive tops and use 1-inch 065 wall stainless tubing for the more expensive tops. We always try to sell the more expensive, but you can't always do it. One of the other parameters that we use is this. Once a top exceeds 84 inches wide, we automatically go to 1-inch stainless steel and we charge for it. Why? Because anything past that, the top has a tendency to sag in the width, and we don't want the aggravation from the customer. So these are the two kinds of tubing that we normally use. Okay, now that we have that problem solved, I'd like to spend just a little bit of time on a typical work order for a convertible top frame for a boat that we've already measured. You'll notice that on here we've got the date and the kind of the boat, the kind of material that's going to be used, the fact that we're going to use 7/8 aluminum with nylon fittings, customer's name, and what we have done ahead of time in measuring the boat is we used the bent tent pole to measure for this particular top, and we found out that the leg length for the main frame was going to be 54 inches. The leg length for the secondary frame is going to be 29 inches, and we're going to have a 52-inch mounting point with a 45-inch layout. So what we did, in order to make an intelligent estimate, we added up those figures to see how much tubing we had to charge for. And if you add up these figures, which are used in conjunction with the formula with the bender, we found out that we needed one length of tubing was 133 inches, and the other one was 83 inches. Consequently, if you add those two up, they come to less than 240. What that tells us is that we're going to get this out of a 20-foot length of tubing, so we charge the customer for a 20-foot length of tubing for this top. So now I'm going to show you how we go about laying out the tubing, marking it, cutting it, and bending it. And we don't try to remember things. We put it up on the wall so that we can look at it, because there's too many places to make a mistake. We try to use the table and the ruler to our advantage all the time. I have a 20-foot length of tubing here. I need a 54-inch leg for the main frame, and we use a Sharpie for marking the tubing because it gives us a sharp mark that'll stay on the tubing. And we have a complete system of marking that you have to use with this bender only because of this. If one person in the shop knows it, everybody else in the shop knows it. So if somebody starts a set of frames and walks away, somebody else can pick up where they quit and keep going. So here's what we do. The first leg is going to be 54 inches. I'm going to measure from the end of the tubing up 54 inches. And I'm going to put an arrow on the tubing, and I'm going to put it roughly halfway around the tubing. And that's what it looks like. Now, to continue using the table to my advantage, because I don't have a helper here, I slide the arrow up to this 2x4, which is our backup board. And the formula for this bender says to do this. Mark the leg length, take the layout width minus 20 inches to get to the start of the second leg length. So I'm going to take the 45-inch layout width, which is what I want, deduct 20 from it. I'm going to measure over here 25 inches. I need to stop there just a minute and tell you this. That formula is cast in concrete. It's on every frame that we ever use. Why do we deduct 20 inches? Back when I designed the bender, it was a figure that was always constant. It was a figure that anybody could deduct from any other figure in their head without a piece of paper. The reason it's 20 is that you'll find that there's 10 inches of width built into the leg here. Consequently, there'll be 10 inches over on the other side. So this is why we always deduct 20. So I'm going to take 45-inch layout, deduct 20, come down here to 25, and I'm going to put another arrow that matches that one. And there's what it looks like. Now, what I would not be picking it up, I'd be leaving it lay right there. And while I've got my ruler strung out here at the 25 inches, I come down here and put the center line of the frame, which is at 12.5 inches. And that mark is a slash with a C through it. Then to crown the frames, we put as many 8-inch marks as we can get on each side of center, and it's in the form of a slash across the frame. To get the next leg length, we come down here another 54 inches from the start of this leg, and this is how we spell cut in Florida. We put a K here, and that's where we're going to cut it. I've now got the main frame all laid out, ready to cut and bend. Now this bender, as opposed to some of the other benders, works as a vise. Other benders, you have to either put a pair of vise grips on the tubing, put it in a vise, put it in a chop saw, any number of ways of getting it to hold it. Or you got to have 3 goons lined up down here hanging on to it while you're cutting it with this big hairy number 2 rigid pipe cutter. And we do use a number 2 rigid pipe cutter for the simple reason that it's overkill on aluminum, but it works like $1,000,000 on stainless steel. And it'll last you a whole lifetime. So this is what we use for cutting our tubing. To use the bender as a vise, what I'm going to do is put the tube into the bender, put the leg length on the leg length mark on the bender, and it's built right into the bender here. Turn the marks till they face my body, get out here at the end of the tubing and bring it around to about a right angle and let it spring back, keeping it level in that groove. Let it spring back, force it into the bender. If you put it into this groove, and this backup, it'll hang there. And it won't turn. So now it's a vise that won't goof up your tubing. Come down here to where it says K for cut. Put a little bit of pressure on it. Put your tubing cutter on here and cut it off. All right, the next step that we do is this, and this is where common sense will help you. Our secondary frame, see if I can get that to fall. Our secondary frame is calling for a 29-inch leg and 45 inches minus 20, which is the same as the other frame, right? But the reason we do it in this sequence is this. It catches you making a mistake so that you don't waste a lot of tubing. So I'm going to measure down here 29 inches, put another leg length on, put my ruler away, bring it over here and lay it up to the main frame and match up the leg lengths. And if you match up the leg lengths like this and copy all of these marks, and with it laying there, measure down another 29 inches and put another leg length and put K for cut. Now the reason I do it in this sequence is this. If I wanted to double check my work, I would measure from leg length to leg length and add 20 and see if it came up to my layout width, okay? I usually don't do that, but if I wanted to double check it, I would. So here's 25 plus 20 is 45. That's what I started with. Without even picking up my ruler, I can look down here, and this leg is approximately half the length of this leg. Consequently, I must be pretty close to right? Now, I want to back up just a second. On the measuring system that we use to design frames, it's not real highly scientific. But while you're making a scale drawing with a piece of graph paper, I can have the frames designed, cut, bent, and cut off 3 more times while you're finding your graph paper. So we use the old-fashioned farm boy way of measuring it, put it on the boat and cut it down. Usually I don't even have to touch it. But this system is not down to the last inch. So I would rather have to cut a frame off than I would have to try to add to it because it doesn't work. Okay, I got my secondary frame laid out and double checked. I'm just going to lay it aside. Now I'm going to finish bending the main frame. Put it back in the bender, put the leg length mark on the leg length mark on the bender. Get it level out here. If it's laying on a table like this, it is level. Keep it in the groove. Use all the leverage you got. Bring it around to about a right angle. Let it spring back. Let the bender hold it so that you don't have to bend over and pick it up because I'm too old and lazy to do that anymore. So I let the bender hold it while I walk around here. Pick the frame up, put the center mark on the crown mark, and that's this mark on the bender. It's marked CR for crown. Put the center mark on the crown mark and bring it around until it kisses the bender and quit. When it kisses the bender, quit. Don't try to second guess it because it will not do anything except put a kink in it. Try to go to the next mark. If you can't get to the next mark, you don't need that mark. Long time ago, this was designed to put the proper amount of crown in for the width of the frame that you are bending. So what I'm saying is, the wider the frame, the more crown. Narrower, less crown. But they will all have some crown. Flip the frame over, put the center mark back on the crown mark, put your hand up against your hip, use your whole body, don't try to be a bull, do it the hard way. Walk into it, bring it around until it kisses the bender and quit. Pull it into the bender, let the bender be a vise. Now is when you start measuring to check out your frame. And to make a symmetrical frame, what we have to have is a frame that's 52 inches wide down here at the mount with 2 equilateral triangles measuring from the end of the leg to the center mark on the frame. I've got 55 inches there. And I lost my center mark. And on this triangle, I've got 56 inches to the center. This one I got 56.5 inches to the center. So what that's telling me is this. My frame is a little bit too wide yet. This triangle is larger than that triangle, right? So all I have to do is flip it back over in the bender. Put the leg length mark on the leg length mark on the bender. Get out of here, get your arms out straight. Take all the spring out of it. After the spring is out, then watch it bend. It only takes a little bit. And when you're this far out, it only takes a little bit of pull here to create a lot out the bottom. Now I'm at 52. Which is what I'm calling for up there. 54.5 on that triangle. 54.5 on that triangle. So now I've got a symmetrical frame with a crown in it. Thusly. All right, now when you're bending frames, the main frame is the one that you bend first every time. And you spend the time to get it totally symmetrical. Once it's bent, then you hang it up on a pair of tubes like I've got up here on the wall, and I'm not even sure if this is wide enough. It's not. But normally we hang it up there on the wall. All the succeeding frames have to match that frame. Don't start trying to make the secondary frame match by dimensions, because this frame is the only frame that will ever be 52 inches at the mount, because this frame gets progressively narrower as it goes up. We don't know what this dimension is for the secondary frame. We have no need to know it. All we know is that the secondary frame is going to match the main frame. Here's your secondary piece of pipe. And again, you guys are all stronger than I am. It can be a big bull and pull that around, but the problem is you have no control over it and you could kink it. So we have a helper here. His name is Bill. It's a 3-foot piece of 1-inch water pipe with the burr taken out on the inside. And I see some people laughing, but this is Bill. Wait till I show you Ethel. She comes up later. Put the leg length mark on the leg length mark on the bender. Get out here on Bill and use all the leverage you got, because when it comes to stainless steel, you're going to need it. You thought I'd forgot how to use that for a vise, didn't you? Scared me for a minute, too. Now we're going to bend the other leg on the secondary frame. Leg length mark on the leg length mark on the bender. Level on the table. Take Bill, pull it around to a right angle, and let it spring back. Walk over here, put the center mark on the crown mark. Bring it in till it kisses the bender. Flip it over and do the other side. Always do both sides of center. Lay these two frames up there and see what you got to do to correct it, okay? These two frames, I got a little carried away and brought them in. The nice part about this bender, as opposed to some of the other ones that are on the market, you can't fix a problem. This one you can fix a problem. This leg has got to come out a little bit. Put it in the bender. Let the bender support the crown. Come over here and push on it with your leg and move it out a little. That leg had to go out more than this one. Let the bender support it. Now I've got the legs pretty close, but I've got some twist in the frames, okay? And you're going to get this with any kind of bender. You're going to get a little bit of twist in the frames unless you've got perfection. And I have never seen a place where you got perfection on bending unless you've got several $1,000s tied up in it. So rather than let this upset me, I take a look at and see which frame has got the twist in it. And it's that one right there. If you all look at it, you can see all the twist in it. Usually we put this under the truck tire, and I goofed today. I don't have anything to put it under. But normally we'll put this under something that's real heavy so we can pull it back into shape. Now you got a set of frames that match. If you line your center lines up and your leg lengths, you got the same amount of crown in them, and you got two frames that match. That's all there is to bending a set of convertible top frames. Now normally, like I said before, usually we have these two pegs up here on the wall 4 feet apart so we can hang a set of frames up. And a lot of some of these frames are so small they won't go up there, but we usually hang them up there. But the other way to use the bender, put the frames in here, assemble your fittings, and put them on. So the next thing I'm going to do is get busy and get the eye ends and the jaw slides and assemble these frames. All right, now we're at a point where we have to assemble these frames to put them on the boat. But before I do that, I've got a little statement I have to make. John Wayne is my hero. And back several years ago, I wanted to wear a gun, and my wife said, no way. So I am now the proud owner of the fastest shears in town. So this is why we sell holsters with shears and all these tools in them. The reason I bring this up is I got a laugh out of some of the audience, but the main thing is this. I get hired to travel around the country and try to help people figure out why they're not making money. And I can guarantee you that the average shop will lose an hour a day looking for their tools. So that's why I have the fastest shears in town. I got a screwdriver. I got 2 screwdrivers. I got a T-Allen wrench, and I got all my marking equipment and my snap dies and my idiot stick so that I can go to work in the morning and get my work done. Because my theory in life is work hard, have fun, and make the most amount of money with the least amount of effort. So with that little speech, I'm going to go into some more on fittings, okay? Some of you people don't know what all these fittings are, so I'm going to explain them to you. And we have basically 3 kinds of fittings that we use. We use white or black nylon fittings for the least expensive top that can be made, which we don't even like to use. Or we have the Zamac fittings, which we don't like to use either, but they are a little more expensive but less expensive than stainless steel. And then the other fittings that we use are stainless steel, thusly. So it gives you 3 different options to offer the customer. It also, I think I told you somewhere back down the line that we stock 7/8 aluminum tubing and 1-inch stainless steel and no other ones. Why? Because if you stock all the different sizes of tubing, then you have to stock all the fittings that go with them. Pretty soon your inventory is totally out of control, and we're very aware of keeping our inventory in control. When it comes to assembling fittings on the boat, we go to the bins, we pull out the number of fittings that it's going to take to put this top on the boat, which is 4 eye ends, 2 jaw slides, and 2 mounting brackets. And I've found that it's a lot easier to assemble them right here on the bench than it is down on the floor. And the reason we assemble them on the bench is this. By putting the eye end and the jaw slide together here on the bench, we can line all the screw heads up the same direction. Why do we line them all up the same direction? So that when we put them on the frame, the screw heads will be facing in towards the center of the boat instead of out. Why will they be that way? So that if you get clumsy and you drop one, you drop it in the boat instead of in the water. The better reason for it is that when you put it on the frames with the screw heads facing in and you're hanging curtains on the side, it doesn't scratch the curtains, which gives you a better quality job. Again, if these frames were wide enough to hang up on those pegs on the wall, I'd be doing it up there. They're not, so I'm going to do it the hard way down here on the bender. Slide them on so that the screw heads are facing in. Bring them up here until the leg lengths on the frames match. Tighten up the set screw on the eye end. Come over on this side. Leg lengths match on the frames up there. Twist them up into shape so that they're perpendicular to the frame. Tip it up and tighten up your jaw slides. The next question probably will be, and you don't even need to ask, it is, what is the dimension from the end of the frame to here? It doesn't matter, because if the frames were cut and bent to the right proportions when you designed them, and you line them up so that the center marks and the leg lengths match up, then it automatically lines up. You don't have to worry about what that dimension is. Now your frames are assembled, ready to go onto the boat. The only other thing you have to have is your mounting brackets and your eye ends for the bottom. And we usually put them on the boat. We can put the eye ends on here, and then we would go out to the boat and put the jaw slides on or the mounting brackets on the boat. While we're discussing mounting brackets for a minute, it may not apply to this boat, but let me go through them for a second. When you look in your supplier catalog, you see all kinds of fittings in there. And everybody says, well, what fittings do I buy? Well, years ago we bought 90-degree mounting brackets, period. That was used on everything. Then they started taking the combing on the boat and kicking it off 5 or 10 degrees so that it gave a nice rounded look to the boat. So finally, after enough years of complaining, they finally came out with a 80-degree offset mounting bracket, which means that it's offset by 10 degrees. And so when you buy your stock, if you'll try to stock the majority of your mounting brackets as an offset bracket and a few 90-degree, that will be the one that'll sell the most. That's the standard mounting bracket. Here's a new style mounting bracket that just came out, and I'm telling you now because the newer windshields are rounded, and most of the tops now are mounted on the windshields as opposed to down on the deck. And this is a new mounting bracket that I helped a guy design. It's out of stainless steel, and it will fit the framework that Taylor puts out on their tops or their windshields, and many of the other companies are manufacturing windshields. It does take a fast pin. It does not take a screw to hold it on. While we're at it, let's talk a little bit about our mounting brackets. This is an 80-degree offset mounting bracket with a screw in it to hold the eye end. This is the most popular popular style of mounting bracket that you're going to use. Now these come with a screw in them. You can also take the screw out and drill it for a fast pin, the same as this fitting over here uses. What you do is take the screw out, drill the threads out of the fitting with a 1/4-inch bit so that the fast pin will go into it. This, by the way, is a 1/4-inch fast pin that's made for the fittings. It has a ring on it plus a stainless steel lanyard and a little clip on the end so that you can screw it down to the boat so the customer doesn't lose it overboard. And they'll love you for that. One of the things I need to talk about while we're talking about these fittings is this. This is a stainless steel eye end. Has a set screw in it. All of our fittings have set screws in them, and one of the bad experiences I had in my life was this. I did a job on a boat, and I used the set screws as they came with the product. We had a storm go through that night that took my top off of the boat, pushed it through the side of the boat, ruined my top, and put holes in the boat, and took antennas and everything else off. So I called my insurance company, and I said, I got a problem. And they sent an adjuster out there, and he spent 3 days finding out how he could get out of paying for my problem. And he won. And the reason he won was I used the eye ends on the end of a piece of tibbing as a stanchion, which was pulling on them as opposed to compressing them. And he said that I should have known better than do that because these set screws would not hold. So consequently, myself and all of the quality shops that I know in the U.S. today, when they get the job totally done and totally adjusted, the last thing that they do is take out all of the set screws out of all of the fittings and replace them with a 3/16 stainless steel rivet. That way it locks it securely to the frame so that it cannot pull apart. And because of the fact that everybody in the world's out trying to sue somebody and get something for nothing, this is what happens. So we guarantee that our top frame will stay together, because if it does come apart, somebody's going to get hurt. The tool that we put these in with is a hydraulic rivet gun that Marine Canvas Training Institute has come up with to sell, which is about the only rivet gun that the average person in this business can take and break off a stainless steel rivet. Because anybody that's broken off a stainless steel rivet with a hand rivet gun knows what I'm talking about. It'll rattle your brains the first time you do it. This you can do it with one hand. So once again, make sure that you replace all of the set screws and all of the fittings with a stainless steel rivet so that it's locked on the frame. This about concludes my frame bending demonstration, but I would like to impress on all of you people that this is one of the greatest ways in the world to make money, because many canvas shops do not sell frames because they don't know how to make them. And I've tried to give you the ways of measuring for them and the systems of bending them, and I think you watched in the demonstration how easy it is to make money using the system. But you got to get a system and stay with it. And it doesn't matter whether it's my bender or somebody else's, but get a system and use it. But it's a great way to make money. Thank you.
The Marine Canvas Training Institute offers 1-week in-residence training seminars for basic boat canvas, advanced boat canvas, and boat upholstery, weekend training conferences, and daily one-on-one consulting. You may order other tapes in the Institute's video classroom series and the Marine Canvas Optimizer, its computer estimating program, by telephone or mail. Also available from the Institute are tool holsters, the Bend-Right Bender, the Bent Tent Pole Measuring Tool, Don Wedge's patented stainless steel snap dies, and other tools and equipment to help you run your business more effectively. For more information and a catalog, call, write, or fax the Marine Canvas Training Institute.